I am Nidhi, working as assistant professor, Gpcet-Cse-Cse-Unit College of Engineering and Technology. Today we will discuss the second unit in the computer network, that is data link layer. These are some of the very important topics where we are going to see, that is the introduction to the data link layer addressing, error detection and correction techniques, cyclic code, checksum, forward error correction, data link control, protocols and services, and other important data link protocols. In this slide, we are going to see the second half of the data link layer, that is medium access control sublayer. The medium access control sublayer mainly dealing with very three important protocols like random access, controlled access, channelization. Here the another concept with connecting devices on virtual LAN. The overview of the data link layer, that which is going to transform the physical layer with the raw bits to the link responsible for node-to-node communication. Some of the specific responsibilities of a data link layer are framing, addressing, flow control, error control, and media access control. In this figure, the data link layer, that which is going to access the services from network layer and provide to the physical layer. What are the data link layer design issues? The services provided to the network layer are not to send the packets to the neighbors without worrying about the details of where they are in one piece. Framing. Framing is considered as the physical layer bit stream into the unit called as frame. Frames are nothing but the packets or messages. By the convention, we use a term called as a frame. Error control. Sender checksums the frame and transmit the checksum together with the data. This receiver recomputes the checksum and compares it with the received value. Flow control. Prevent the faster sender from overwhelming the slow receiver. Providing the well-defined service interface to the network layer. The physical layer which is not going to deal about the transmission errors, but in the data link layer we are going to see this. Regulating the flow of data so that the slow receivers are not stopped by fast senders. In this diagram, the sender mission sends the packet, which is formed as a header, payload field, trailer, which is called as a frame, forwarded to the another side of receiving mission. College of Engineering and Technology. Today we will discuss the second unit in the computer network, that is data link layer. Unacknowledged connectionless service, which is consisting of the source mission, which sends independent frames to the destination mission without having the destination mission and acknowledge them. We are not going to establish any logical connection before or release afterwards. If the frame is lost due to the noise on the line, no attempt is made to detect the loss or recover from it. This class of service is appropriate when the error rate is very low, so that the recovery is left to the higher layer. It is also appropriate for the real-time traffic such as voice, in which the late data or those than bad data. The overview of the data link layer, that which is going to transform the physical layer with the raw bits to the link responsible for node-to-node communication. Some of the specific responsibilities of a data link layer are framing, addressing, flow control, error control, and media access control. In this figure, transmission of the page, third page, and finally connection page. After transmission of the data by using the router process. Framing. In this data link layer, translate the physical layer raw bit into the discrete unit called as frame. For this, we are going to see a very simple diagram how the frame header, packet header, TPDU header is formed. We are going to see the different types of framing techniques like character count, flag byte with byte stuffing, starting and ending flags with byte stuffing, encoding violation. The problem is the count can be garbled by the transmission error. The overview of the data link layer, that which is going to transform the physical layer. Here, in this slide, we are going to see how the frame transmission is going to be happened by using start text and end text DLEs, which are added at starting and ending for each and every character that which you are going to forward. By adding these or attaching the DLE STX so that the data can be forwarded from source to destination, so that in between each and every character DLE escapes are going to be placed. So we observe that how the data is going to be forwarded based on character stuffed by the data link layer, and that which you are going to forward to the receiver, and the receiver is going to receive the data after escaping bits that which has been added. This is another example where we are going to use flag bytes at the each starting and ending of the frame that which you are going to forward. Next one is bit stuffing. In this technique, we are going to see how the data frames contain an arbitrary number of bits that which allows the characters with an arbitrary number of bits per character. In this, we are going to use adding of a 0 for every 5 consecutive ones, so that we are going to send this data to the receiver. The receiver, as soon as receiving the data, is going to destuff the 0 where we have been added at 5 consecutive ones. This is an example where we are going to see for every 5 consecutive ones the 0 has been added, and we are going to consider this as a character 1 and character 2. At the receiving side, the 0 is going to be removed. Next, coming to this physical coding violation. In this, the bit stream has to be forwarded from source to destination, and we are going to represent this bit stream into a binary encoding format, where whenever the 0 occurs, the rise in the signal, 0 occurs, down in the signal. And again, we are going to use a Manchester encoding mechanism. The combination of high, high, low, low are not used, but high to low, low to high are used for 1 and 0. Good evening. This is G the flow control, that which is going to deal with throttling the speed of the sender and the receiver, where the sender and receiver speed should match. Here we are going to see two techniques. One is feedback based flow control, second one is rate based flow control. In the feedback based flow control, the sender is expecting a feedback from the user, the receiver, that it has to give the permission to send more data, or at least telling the sender how the receiver is doing. Coming to the second one, rate based flow control, the protocol has built-in mechanism that limits the rate at which senders may transmit the data without using feedback from the receiver. Next, error detection and correction. It is physically impossible for any data recording or transmission medium to be 100% perfect. Over the time, it's expected, but what is the reasons for error occurring possibilities are like noise, lightning, telephone repairment, signal attenuation, and some of the natural techniques. In this, the detection and error correction requires the redundancy or extra bits in order to send along with the data. We will go with the two types of errors are there. Single bit error, where only one bit of a data unit is changed from 1 to 0 or 0 to 1. Coming to the burst, where a group of bits in the data unit are changed from 1 to 0 or 0 to 1. Here we are going to consider based upon the length of the error that which has been occurred. Coming to this, we are going to use the error detecting and error correcting codes for transmitting a data by attaching the redundancy bit, where at the sender side a message plus generator is going to be forwarded, which is known as message and redundancy bit. At the receiving side, we are going to place a checker. The checker is going to check whether the data is correct or not. If it is correct, accepted. If it is error prone, it is discarded. We are going to see some of the detection techniques like VRC, LRC, VRC and checker. Coming to the VRC, where we are going to append a single bit at the end of data block such that the number of ones is even or odd parity, where the number of zeros, that is going to tell the user or the sender whether to make the odd or even parity. VRC is also known as parity check. In this we are going to see how the data is forwarding by adding one extra redundancy bit, which makes and complete information, and we are going to forward to the receiver. This is another example for VRC. In the LRC, a longitudinal redundancy check seeks to overcome the weakness of simple bit-oriented one-directional parity checking mechanism. In this, LRC adds a new character called the block check character to each block of a data determined by parity but counted longitudinally through the machine, which is going to detect the 98% of the error. This is the example for two-dimensional parity check, where we are going to see how the data bits has been arranged in longitudinal and vertical, and we are going to see the one error effect, two error, three as well as four errors, where the two-dimensional check works for one error, two errors, but not for four errors. This is cyclic redundancy, which is a technique for detecting errors in the digital data but not for making the corrections. When the errors are detected, it is usually primarily in data transmission. In a CRC method, a certain number of check bits, often called as checksum, are appended to the message being transmitted. The receiver can determine whether or not the check bits agree with the data to ascertain with a certain degree of probability whether or not an error has been occurred. It can be easily implemented with a small amount of hardware with shift registers or XOR with addition or subtraction. These are some of the steps where we are going to follow for generating a polynomial, and whatever the data that this is existing with that, we are going to add extra redundancy bits by using the number of bits that which are existing in a divisor -1 and forwarding a data. If the remainder is getting as a 0, accepted, non-zero means rejected, which is also simply known as the frame check sequence. This is another representation with how the m of x can be considered as message polynomial, p of x as generator polynomial, and in order to get the cyclic redundancy check value, we are going to divide and get the final value. Sending side and receiving side, initialization. This is cyclic, and this is example where we are going to see with the frame and generator by appending the 4 zeros at the end of the frame. Finally, we are going to get the remainder as 1110. Again, this 1110 has to be added, and we will get a 0 where the CRC check is passed. This is a polynomial representation of data, appending the bits and dividing the message and generator polynomial, where the remainder is x square plus x, which is also represented in the bit format with 0110. We have different types of CRCs like CRC 8, 10, 16, CRC 13, and how the CRC performance that works in case of detecting the single bit, double bit, any odd number of errors, whereas CRC 12 detects 99% of errors in the length or more than that. The overview of the data link layer, that which is going to transform the physical layer with the raw transmission, raw bits to the link responsible for node-to-node communication. Some of the specific responsibilities of a data link layer are framing, addressing, flow control, error control, and media access control. In this figure, the data link layer, that which is going to access the services from network layer and provider. In the LRC, a longitudinal redundancy check seeks to overcome the weakness of simple bit-oriented one-directional parity checking mechanism. In this second example, second example. This is cyclic redundancy, which is a technique for detecting errors in the digital data but not for. In the Hamming code, we are going to use a technique that is the relation in between the message bits, where we need to identify the number of data bits, redundancy bits, total bits. How can we form with the redundancy bits means the 2 power n logic, 2 power 0, 1, 2, 3, 4 like that. And this is going to give the values like this. If the number of data bits is 7, the positions of redundancy bits are occupying with 1, 2, 4 and 8. The remaining 3, 5, 6, 7 are occupied with the 1001101, and we have added the having code redundancy bits of 1001 with the positions of 1248. Finally, we are going to receive the data, and the problem is the count can be based on